This is a review for our first 9 weeks. I will record this in multiple parts so that it will not be a long video. So let's start with part 1. The population of Sellersville is modeled by the function f of x is equal to 2,350 times 1.05 raised to the x power, where x is the number of years since 2010. Use this information to answer the questions 1 through 3 below. So we're going to know that how many people live in Sellersville in 2010. So that is our initial value. And I'm going to get this pen to start writing for me here. Move it down here. And our initial value is, remember, the same as A. Okay, and our formula, so our initial value is 2,350. So that's how many people live in Sellersville in 2010. Is the population of Sellersville increasing or decreasing by what percent? So we know that if we look at our B value, our base, and that base is greater than 1. So we know it is increasing, and it asks by what percent. So we know that our base is 1.05, which is equal to 1 plus R. If we want to solve for R, we subtract 1 on both sides. And remember to add and subtract decimals. We have to line up our decimal points. So R would be equal to 0.05. That would be our rate as a decimal, and as a percent, it is 5%. By moving that decimal places, 2 places, moving the decimal point 2 places to the right, we get 5%. So we know that it is increasing by 5%. Approximately how many people are in Sellersville today? 2010, which is 10 years from 2010. So today, 2020, which is 10 years later, how many people will be in Sellersville? So we take our equation or our function. F of x is equal to 2,350 times 1.05. X, they told us, is the number of years. So we'll replace the x with 10. We'll put that into our calculator, and it would be approximately 3,828 people. We have to round it off to the nearest whole number. Number 4 through 6 is matching. Number 4 is quite easy because it is the only one that actually has an inequality symbol. Remember, your inequality symbols are greater than, less than, greater than or equal to, or less than or equal to. So we know from that that number 4 is C, an exponential inequality. Number 5 is A. It's an expression because it does not contain an equal sign. And number 6 is B, an exponential equation because it does contain an equal symbol. Write the part of the equation in the correct vocabulary word. 23.99 is equal to 12 times 0.08 raised to the 9th power. Again, 23.99, that's our final value. That's our f of x, or we can also known as y. Our initial value is 12. Our base is 0.08, and time is 9, which is also represented by x in the formula at the very top of the page. Number 8, A company in Augusta pays its employees $35,000. Okay, that's some information I need. Their pay increases by 8% each year as a reward for their hard work. If the company can pay its employee no more than $61,000, how many years, that's our time, can an employee expect to get a pay raise? Now, we have the keywords no more than, so that lets me know that this is going to be an inequality. Remember our formula? This is dealing with y is equal to a times 1 plus r. Try to take that back. 1 plus r raised to the x power. Why? Because an employee can earn no more than $61,000, so that would be our y value or our final value. R is the rate of 0.08. Our initial value, the company is paying its employee currently $35,000, so that would be our initial value. And we do not know the time. Okay, because the question asks how many years. So if we write it in our format, y, put this in a different color. Y is equal to a times 1 plus r raised to the x power. Our y is 61,000. Since they cannot make no more than 61,000, we know it's going to be greater than or equal to. So our initial value is 35,000 plus our rate. Remember, we have to add 1 to that 0.08. So I'm going to come down here and try to rewrite it. 61,000 greater than or equal to 35,000 times 1.08. And I cannot seem to get all of that on the same line. So I'm going to go back up here and erase this and rewrite it for us. Okay, so here we go. Let's try it again. Y is equal to a times the sum of 1 plus r to the x power. Our final value is $61,000. Our rate is 0.08. Our initial value is $35,000. It's how much the company is starting out paying, and we do not know the time. So we go and plug into the formula. Y equals a times 1 plus r raised to the x power. So y is our final value. So that's 61,000. And because it says no more than, again, greater than or equal to 1 plus 0.08 raised to the x power. If I add 1 plus 0.08, 61,000 is greater than or equal to, and I left out that a part. So please forgive me, that should be 35,000 because that is our initial value times 1.08 raised to the x power. So do not forget your initial value in there. Moving on to number 9. Susan loves watching her garden grow. Her rose bush currently has 7 roses. Sounds like an initial value if it currently has 7. And it's expected to triple. Currently has 7, expected to triple each month. How long will it take for Miss Susan to have at least 150 roses? So we have at least 150 roses. Our y is equal to 150 because that's how many roses we want at the end. Our a is equal to 7 because that's how many she's starting out with. Her b, the base, is triple, so we're going to use 3. And we do not know the time. We don't know how long it would take. So we know this will be an inequality. Y is equal to a times b to the x power. So it's 150. Because it is at least, it has to be less than or greater to 7 times 3 raised to the x power. Remember, triple means times 3. Number 10, a computer depreciates 15%. So if it's depreciation, we know that that's going to be a decrease. It decreases annually if you buy the computer for $950. So if I buy it for $950, that sounds like my initial value. That's what I'm currently paying for it. How much will it be worth in 3 years? That's my time. Okay. We don't know the value in 3 years, so we don't know our Y. We know our initial value of $950. We know the time, which is represented by variable x, is 3 years. We know the rate that it will depreciate is 15%, and as a decimal, that's 0.15. So if we go in and use our formula, y is equal to a times 1 minus r raised to the x power. Y is equal to my initial value of 950. 1 minus 0.15 raised to the third power. But we're not done because we need to simplify 1 minus 0.15. So that'd be y is equal to 950 times 0.85 raised to the third power. Number 11, the decay. So we know immediately decay, we know it's going to be decreasing. Of a certain type of organism is such that 1/4 of the cells remain every hour. If after 3 hours you have 24 cells remaining, that sounds like after the 3 hours. So here we got time right here, time. This sounds like, excuse me, this sounds like our final value. So how many did you begin with? So we know that we're going to end up with 24 cells at the end. That's our final value. We don't know how many we begin with, so we don't know our A value. Our base is 1/4 of the cells remain every hour, so our base will be 1/4. And we know the X is our time of 3 hours. So y is equal to a times b to the x power. We know our final value is 24. We don't know our initial value, so we will keep the a, and it's 1/4 times 3. So that is part 1 of your review.